Welcome to the final week of our course. This week, I'll discuss about the current challenges, sustainability and environment implications in 3D concrete printing point of view. Also, we're looking into the future trends in the practice, as well as the research directions. Let's begin with the current challenges in 3D concrete printing. The first challenging point is orthotropic or anisotropic behavior. In our exploration of 3D concrete printing, we encounter some substantial challenges, and one of the most crucial is the orthotropic mechanical behavior, resulting from additive manufacturing or layer deposition techniques. Throughout this course, we've mentioned the significance of the orthotropic behavior a lot of times, but it's never enough to highlight its importance. The layer-by-layer deposition process introduces anisotropy into the structure, which translates to the distinct mechanical properties in different directions. Think about the orthotropic materials like wood, rolled steel, or certain other crystals. There's inherent variation in strength and stiffness according to load directions as a layer of complexity to structure design. To ensure that the structure can safely bear intended loads, it necessitates meticulous nonlinear analysis and careful planning, which in turn can drive up the construction cost. Traditional construction method operates under the assumption of that concrete material is isotropic material behavior, simplifying structure analysis and design. However, in the realm of 3D printed concrete structures, we must adapt our conventional design approaches significantly to accommodate these orthotropic complexities. The second challenging point is reinforcement strategy. This challenge can be considered as an extension of the first point. Concrete is rarely used as a sole structural material. It typically requires a steel reinforcement placed strategically to support various structural components like column, slabs, beams, shear walls, and more. In the field of 3D concrete printing, the volume of steel reinforcement is notably less than what's typically used in conventional reinforced concrete, or that can be called RC structures, due to the distinctive construction technique. The most frequently used reinforcement strategy discussed in our previous session, and week 6, involved using 3D printed concrete shells as a permanent formwork. In this approach, vertical rebars is erected, or a rebar cage is placed inside of the shell. Then the shell is filled with the concrete. While this strategy allows for more extensive rebar use, there is still limited research on structural performance as a whole RC structure under different loadings. Furthermore, there is currently no established consensus regarding the durability of the steel reinforcement within these 3D printed permanent concrete formwork shells. Moreover, the inherent limitation of overhanging printing in the current state of 3D concrete printing techniques make the printing of beams and slabs improbable. This in turn poses a significant challenge for the construction of high-rise buildings using this technique only. The simplicity and streamlined construction processes that are among the primary advantages of 3D concrete printing do not align well with this particular reinforcement strategy. It involves several additional steps and processes, including shell printing, rebar cage construction, rebar placement, and concrete casting, slab placement, and joint connections, and so on. Consequently, we can witness most 3D concrete printing projects are currently focused on low-rise residential building construction. Nonetheless, a dedicated community of researchers, engineers, and professionals is tirelessly working to surmount this challenge. Their collective effort instills confidence that solution will emerge in due course. The next challenging point is lack of standardization and regulatory and permitting issues. Adherence to building codes and local regulation is a non-negotiable aspect in the construction field, primarily due to a direct impact on the fatality and safety. While discussion about global standardization, such as ISO and ASTM, are ongoing, there has yet to be an official regulatory standard published yet. So this absence of standardized like a method, construction method, or the machinery reinforcement techniques can pose challenges in ensuring compliance, especially since existing codes and standards are typically tailored to traditional construction methods for now. So to address this, constructive dialogue between construction professionals and regulatory bodies is crucial to establish clear guidelines and safe guidelines for 3D printed structures. While numerous structural design guidelines are provided by the 3D concrete printing companies within the 3D printing industry, compliance with these guidelines is often not mandatory. Currently, most structural designs are rooted in conventional theories and practice, and which need to be adapted for 3D concrete printed structures. However, some governments are beginning to embrace the new technology, allowing structural design to proceed as long as they are signed off by certified professionals. Like most of the cases are actually done in that way. This signifies the evolving landscape of regulation and compliance within the field of 3D concrete printing. In addition to these primary challenges, several minor obstacles exist, such as material consistency, adherence to regulations regarding printing machineries and construction process, which has not been published yet, quality assurance, surface finish, and crack management, among others. However, it's important to emphasize that three main challenges previously discussed are the most critical factors that must be addressed to render this technology practical for real-world applications and gain public acceptance. Given the inherent conservative and slow pace of the building and construction industry, the adoption of 3D concrete printing is expected to be a gradual and slow process. However, I'm confident we are moving in the right direction. I encourage you to keep an eye on this rapidly evolving field, and let's anticipate the innovative solutions that lie ahead. For now, let's take a brief pause and look forward to rejoining you in the upcoming video, where we will dive into the sustainability and environmental implication of 3D concrete printing. Until next time.